Alright, my name's Kyle and this is my week 4 summary for Physics 101. So we'll be going over everything that I learned this past week. So we're going to start with the stuff that we did in class. So I'm just going to move to some pictures here. And there it is. So this first one is a graph of the pendulum motion we did by uh, attaching an object to a string and just letting it swing back and forth. So this is the blue is going to be the Y position. So as you can see, it really doesn't move too much, while the X is how it moves left to right. So that one's kind of moving up and down all over the place. So go to the next one, and this is the same thing, the same pendulum. You can just see the Y position, which should be this one. And then the Y velocity is going to be this one as it's swinging, and then it kind of comes to a stop when it reaches the end of a point, and then it starts swinging again. So there's some graphs over the pendulum experiment we did. Next one, if I could zoom in here a little. We did some more equations and calculations with the EG and EK and all that, and then we did a experiment with the spring where we had to take the minimum height, max height, get the average or the difference there, as well as the velocity, and then we had the top, middle, and bottom on how it was like falling up and down the spring. So then we built this table which kind of showed all the figures, and once we found out what the total energy value was, we could figure out and kind of plug in the other figures as we went along. Let's see if we can get to the next picture. Alright, so this one was a Nerf gun experiment where we had to go outside, keep it perfectly horizontal, and shoot it, and then measure the distance that the darts flew. So for our first trial, we got 4 meters and 30 centimeters, which is 4.3 meters. And then we had to go back out and make it shoot farther. So we kind of a little more than doubled the height, and shot it again a couple times, and this time we reached 6 meters 30 centimeters, which is 6.3, which is exactly 2 meters over the first one. Then we had to come back in and we did the same thing that we did on the last slide. Alright, so you can see the difference. This one was 2 meters, and then we had the table down here where we kind of plugged everything in with the EG, EK, and E, that was the springiness. And pretty much did the same thing on the last slide, kind of plugged in the figures as we went. And I still didn't get the velocity, so I'm going to have to do that before the next class. And then here's kind of some graphs that he showed us up on the board. So this was the initial point, and you can see it hits about there. And this is the second time when we elevated it a little higher, and that's when it got to 2 meters, 2 meters more. Now he gave us some more equations to figure out kind of how to calculate velocity and all that, which is right here. And then we had to use this one right here to calculate the time that it took to hit the ground. So it was 0.6593 seconds, so really quick. And then we plugged that time in to here, and that is where we got the velocity. So it's moving at 9.5556 meters per second, which when you plug that into the EK equation gives you a kinetic energy of 0.0457. So that is all the pictures we had. So we're going to go back into Canvas here, and we had a couple things to do this week. We had the Waiting for Superman discussion, which was a documentary that I had actually seen a couple years ago, and rewatching it. It's still as messed up as ever how teachers can get away with doing absolutely nothing, and they're just collecting their paychecks and just kind of sitting back. So it's kind of frustrating. And then the next one was a programming resource. And let me try to find my submission here. It was pretty much just an article that had a bunch of different links for people that are learning to program. So if you're interested in that, you can kind of follow through those links and do the different projects or challenges they have for you to kind of get into it. Next one was a neat resource for hacker maker spaces, and I picked the Create Center at the Arizona Science Center. And I guess they have little workshops where they can teach you how to 3D print or laser etch objects, or I think there's a woodworking one too. And the workshops are a little pricey. They're from 40 to like 75 bucks, but it's still pretty cool that you can just pop down there and walk away with something that you created by yourself. So I thought that was interesting. And yeah, kind of putting everything together. What I learned from this is it's just kind of interesting to see how it's all graphed, and like how to see what an object looks like when it's in a pendulum motion. So that was interesting to see. This one was pretty much the same thing, although you can see the speed of how it's moving back and forth, and as it reaches one end, the speed completely stops because it has to turn around and go the other way. So that was interesting. The notes, it was a little tricky, a little more math this week, so it was kind of cool to learn how to complete a table like this one down here when you only have one or two of the figures. So we kind of had to use some new equations, use some new math to figure it out. And then this one was with the Nerf gun. Kind of cool to see like how much distance you have to go to increase your height in order to go a certain amount of meters farther. And then this new formula was something I've never seen before, so that was looks extremely complicated, but it was interesting to kind of plug in everything and figure out through math the different energy levels and distance and velocity that the darts were actually flying, which was cool. So yeah, that concludes my week 4 summary. I learned a lot this week, and I hope to learn more in the upcoming week. Thanks.